Okay, we're going to continue our light work with some polarization. No, sorry, we're not switching to politics. We're going to talk about polarized light. Okay, what is polarized light? So polarized light is light that vibrates. I'll clarify that in a second. In only one direction. Okay, what do we mean by vibrate? Alright, so you got to remember a little bit about what light is. Light is your electromagnetic wave, right? So electromagnetic waves, that means your electrical field is going to go like this, and your magnetic field is going to be going left and right, right? So you're going to have like a perpendicular axis, like crosshairs kind of thing. But what polarized light does is it's going to only allow, let's just think about the electric field, right? The electric field in one direction, okay? So normally the electric fields from unpolarized light will look something like this. They'll be going in all sorts of directions, okay? You know, you just take it and you spin it, like your fidget spinners that all you kids are so fond of. Now, once you polarize it, you're only going to have the light that is going up and down, for example, as opposed to all these different directions together. All right, let's show you an example of what it would, how you'd polarize something. One example. Okay, we've got this stylish animation here having unpolarized light. So you can see that there's a red, there's a blue, and there's a green in there. Hashtag primary life, sort of. So as this unpolarized light hits this surface right there, it's going to reflect and refract. Now whether it reflects or refracts depends on the angle that it hits, and it also depends on how the light is oriented. Now the red light is basically parallel to this if you lifted it up at that angle, okay? Which means that it will reflect much better than the other ones, okay? These guys, the yellow one is going up and down like in the plane of the screen, right? Your front plane. So it is going to go into the glass, and it's the same thing with the green and the blue one, okay? So the light that will reflect is going to be polarized in the plane of the surface, okay? So you can see that a little bit on the right-hand side. You've got unpolarized light coming from the sun. The sun light is going to bounce off of the horizontal surface of the water. Now this bouncing will polarize the light in the horizontal way as it reaches your eyes. You won't have as much as the vertical light anymore that you can see. And that is what's going to happen when you polarize light. Okay, how can this be useful? Well, this is useful if you ever have any polarized sunglasses. Polarized sunglasses help you to see much more than just making it dark. The reason is, let's pretend you're driving. You have unpolarized light. If it goes right into your sunglasses, it will be dimmer, which is fine and dandy. So you can see outside easier. But if you have a horizontal surface, like let's say a road, it'll bounce off and it'll be polarized horizontally. Now, glasses are polarized vertically, so they only let vertical light through. Now, this is horizontal. How much of it is vertical? Basically nothing. I mean, very little of it, okay? So what light gets through? Only just some remnants. Does that make sense? Because, you know, this isn't going to be perfectly polarized. It's going to be partially polarized. So it's going to be like this. You know, you can kind of see it in the picture until I drew all over it. So once we cut out all the horizontal stuff and only keep the vertical, you're only going to have a little bit of light left compared to a big thing of light left. Now this reduces the amount of light that you get in your eyes from reflecting off of the road surface or the windshield or the mirrors. So this is reducing the glare, because that's what glare is. Glare is a higher concentration of light from reflection, and this will cut out the light that's reflected much more than the light that goes straight into your eyes. This is also how night vision glasses work. I say night vision glasses because they're just those yellow glasses that help old people to see at night, for example. They're just polarized filters with a yellow tint. The yellow tint is so they don't darken everything, but they just block out the glare. That's all they do. They block out the glare while still allowing as much light as they can through that's not glare. Alright? And there's a useful for this. Oh, before we get to the formula, we wanted to show you about movie glasses. This is also how they make three-dimensional movies. They have two cameras, two projectors, right? And one is projecting a polarized signal for your right eye, one is projecting a polarized signal for your left eye. Now, you want to make sure the right eye gets the correct signal, so that's where the glasses come in. Now, they don't exactly do horizontal and vertical. What they have is they have circularly polarized light. This is so if you turn your head to the side a little bit, it's still circular to the right or circular to the left, and that is how they polarize those. So this is going to be from the film right here. Right, so they have unpolarized light from the light bulb inside of the camera, and then they linearly polarize it, and then they curve it. Okay, so that you can see that it goes into a helix around that central axis there. Okay, and that's how they make three-dimensional ones. So it's not perfect, it's not identical to what we told you before, but it's very similar. Okay. So we're going to talk about the formula for polarizing things. If you polarize things, obviously it's going to get dimmer, but how much? It depends on how separated the axes are. Okay, so this one is going straight up and down. You're going to have some angle here. All right, this angle depends on how much you'll block out. If you rotated it 90 degrees, you'd block out basically everything. Okay? So you're going to have some light coming in. Now, automatically, whenever you pass through, you're going to get 1/2 times the intensity. All right? That's for the whole thing. And then this guy, this intensity, is going to be multiplied by the cosine squared of the angle. All right? So, let's do a practice one. Alright, two polarizing lenses are angled at 30 degrees. What percentage of light passes through the whole thing? Alright, so we've got, let's pretend, just 100% coming in to our first one, which is going to be right there. What's going to go into here? We're going to have 50% going into there. Now we have our second polarizing filter, which is angled at 30 degrees, right? So this is the polarizing gradient, whatever you want to call it. And so what do we have to do? We're going to multiply this guy by cosine squared of 30 degrees. All right, cosine squared of 30 degrees. Well, do you remember all this stuff? So cosine of 30 is root 3 over 2. Squared is going to be 3 over 4, so you're going to get 75%, right? But hold on a second, it's not 75% of 100%, it's 75% of this guy, because this is what's coming in here. So we multiply those together, we're going to get 37.5% of the light. No calculator even needed. Too easy. Alright, so that's how we calculate how much light passes through polarizing filters.